Hello, plugin developer community. This is Nikita Katkov, a member of the remote development team at JetBrains. Today, we'll explore what makes a plugin remote development friendly and how to adapt existing plugins for working in a distributed environment. First of all, let's get ourselves familiar with the terms I'll be using. Remote development, or RemDev for short, or split mode, simply means that IDE runs as two separate processes, frontend and backend. The frontend handles the UI, while the backend manages the business logic, works with project, and does all the heavy lifting. We'll cover the following topics in our presentation. First, why remote development compatibility matters to you. That includes what motivates users to switch to remote development, what's wrong with existing non-native remote development plugins, and how the UX differs between a regular and remote development native plugin. Second, we'll cover how to write or migrate a plugin to make it remote development friendly. That includes what project module structure we'll be using, how to set up a front-end-backend communication, how to organize build scripts. We'll also look through a backend front-end specific APIs list. And, finally, we'll assemble a step-by-step refactoring guide. At last, there will be a questions section. Since unfortunately this time it's a pre-recorded video, kindly save your questions until the end of the presentation, when I'll do my best to give you even more information and context. First of all, let's answer the question why the remote development might even be important for you. According to both internal and external surveys, cloud-based development is gaining widespread adoption. Up to 52% of developers have tried remote development solutions, and around 36% of them use them daily. Chances are, your users already need to work in a distributed environment. This info in the slide is taken from the DevEcho survey conducted by JetBrains at 2025 and the State of Application Development survey conducted by Docker. Is there any difference from the UX perspective between a native and non-native plugins? In this slide, you can see the two screencasts. I tried to select the same tree node in both of them. On the left, an action takes a long time to complete. There is a clear delay between the click and the reaction. On the right, an action is instant, and the user experience is very smooth. The node expands immediately after clicking on it. What happens here is simple. If you do nothing with an existing plugin and use it in split mode, you will likely get an experience shown on the left. The plugin runs only on the backend, and every UI interaction goes through the network, which adds latency. This setup works out of the box, but it's slow and frustrating when the connection isn't perfect. On the right, the same plugin was split for remote development. The UI part now runs on the front end, and only data is exchanged with the backend. That's why it behaves fast, just like in a regular monolithic IDE. So, the goal of this talk is to explain how to move from the left side to the right, from lag and backend only to smooth and remote friendly. This slide attempts to demonstrate even more frustrating thing: scrolling. I scroll the mouse wheel at exactly the same pace, starting the same moment on both pictures. On the left picture, it takes about a second for the actual scroll to happen after I touch the mouse wheel. On the right picture, scroll itself happens immediately, just as you may expect from any UI application. It is quite hard to depict the UX through a screencast, but believe me, it's enough to experience it yourself only once to realize how poor the UX feels. The good news is, you can adapt the existing plugin to work smoothly in remote development, making it indistinguishable from monolithic one. But before discussing the ideal setup, let's briefly take a look at the very simple, regular plugin that doesn't know anything about remote development at all. This will help us understand the general idea behind the refactoring approach I'll soon present to you. Imagine you've got a plugin that's simple as in the picture. It implements a go-to-declaration feature for, a protobuf file. Doesn't really matter. The plugin finds a corresponding Python script generated from it and provides ability to navigate there. Very likely, such a plugin looks like this. There is a single plugin.xml file describing all extensions and dependencies. UI and business logic are separated at the classes level, for example via the MVC pattern, but they are living in the very same project module. Plugin descriptor declares a dependency on Python module, as well as registers its extension to do the actual job, look up the appropriate Python files. Now, we want to extend the plugin's functionality by introducing another navigation handler, this time for generated Golang code. Our project has grown, and we've hired new programmers who write their microservices in Go. Okay, let's try making their life a bit more convenient as well. The plugin can now assist both Python and Go developers. But wait a minute, what does it plugin XML looks like now? To be able to access some Go-specific classes in runtime, we had to declare one more dependency on the Go module. Well, currently, our plugin is twice as smart as before. It supports 2 languages simultaneously. What it also does simultaneously, it depends on both Python and Go at the same time. That in turn means that Go developers will have to have Python plugin installed just to be able to work with Go code. That sounds strange, doesn't it? On one hand, luckily, our users can set up the IDE with both languages supported at once. But on the other, does it even make sense? And what would happen when we add more and more features to our plugin? What if only one of features A and B can work at a time? It seems that we lack a way to add the specific functionality to our plugin that will turn itself off in case it's not applicable. And by turning off, we mean not even trying to load the corresponding classes, since their dependencies are not available either. A solution would be to introduce a dedicated module for each independent major feature. Golang code will reside in the Golang module. Python code will reside in Python module respectively. There also might be something in common between the two. Let's put it into a shared module between the two to benefit from reusing the same utility code here and there. Now, we are getting back on track with the remote development, finally. Let's imagine another, a bit more different and complicated plugin that employs an external process to provide some useful data to the end user. Let it be an LSP server, or you can pick any technology of your personal choice. Server returns validation data regarding a file currently being opened. To display the results of validation, the server needs some UI. For simplicity, let it be a dedicated tool window that renders beautiful validation results page. So again, what we are going to do here is to register both tool window factory and the LSP server provider in the plugin.xml file. We were told to do so by the official documentation in the first place. That's right. However, we have now encountered the very same problem we faced with our previous Python and Go plugin that handled both Python and Golang code. The perspective has changed slightly though. Previously, we supported the same feature from different language perspectives. And now, we support the same feature from a UI and inter-process communication point of view. Any chance we can solve the identify problem with conditional loading? Are there any ways to have a single plugin capable of working with many kinds of environments, be it PyCharm or Golang, Frontend, or backend? A remote development native plugin mirrors the split IDE architecture, and it includes a set of front-end specific features enabled only on the front-end, a set of back-end specific features running only on the back-end, and shared logic between the two. So, how do we implement such a layout? Okay, for a while, we've been internally using the so-called content modules concept to handle different dependencies effectively. For example, if your plugin provides Golang specific functionality, but should still run in PyCharm, which lacks Go-related code of course, you can extract the Go features into an optional content module. If its dependencies are not satisfied, that module simply doesn't get loaded, but the rest of the plugin does. Now, imagine replacing Golang with Frontend, PyCharm with backend. Nothing changes, and the very same concept applies. Remote Development Native plugin, therefore, consists of a dedicated Frontend module with mostly UI components and its dependencies, a dedicated backend module with mostly business logic and its dependencies as well, a shared module with common code, mostly RPC interfaces for bridging frontend and backend, a root plugin.xml file listing all plugin modules that can be enabled and disabled independently. On the slide, you may observe a special syntax to use in the root plugin.xml file, should you decide to modularize the plugin you are responsible for. Note how our frontend module declares dependency on platform.frontend to indicate it has to work in the frontend IDE, where the UI is. It also depends on its own shared content module, just to be able to use classes from it. Same goes for the backend module. It depends on platform.backend and its own shared module as well. After creating a few modules, we now have to link or connect frontend and backend code. But how can they communicate without having a direct dependency on each other? Here, we use RPC, or Remote Procedure Call, a familiar concept for many developers. From the example on the slide, you can see a small RPC interface that the frontend uses to retrieve information from the backend. The backend, in turn, must provide an implementation for the method being called. Our implementation runs over a secure protocol, and it utilizes the Kotlin X.serialization framework for data exchange between frontend and backend. By the way, it's coroutine-friendly. On the slide, you may see an example of serializable classes that are transferred through a wire when a function argument is passed from the frontend via an RPC call, or when a result is returned from the backend. Getting back to our sample plugin with good module structure, to make it actually work, we now have to add RPC interface and its implementation to the appropriate modules. And we are good to go. Last but not least question, how do we build a plugin like that? The answer is using the IntelliJ platform Gradle plugin and some of the Gradle best practices. With their help, we have created a plugin template that includes all necessary infrastructure to start development right away. This template provides a multi-module Gradle project with properly configured dependencies between frontend, backend, and shared modules. There are a bunch of tools in our Gradle plugin to tweak the IDE you are building a plugin against. Among others, there are remote development configuration options depicted on the slide. Should you decide to test an old plugin installed solely on the backend, or play with its new version available on both ends, everything is possible out of the box. The template also includes RPC and serialization plugins extracted into the so-called Gradle convention plugin, and the example feature implementation as well. Namely, it is a mock AI chat, because it's never too many of them, I guess, right? The presentation will of course be shared by conference organizers, and you'll be able to look through the links given in it, including the template, of course. Please refer to it when it comes to splitting the existing or writing your new plugin. What else do we have to cover? It's a general guideline, which APIs to use where. The platform does have a lot of them, and it's not obvious which things belong to frontend, to backend, or can be touched anywhere regardless the IDE mode. I'd love to get you familiar with a short list of core APIs one should use on either frontend or backend side. First, consider having the following API usages in your frontend module. Any UI components, dialogues, be it tool windows, editor UI, JCF browser, etc. Secondly, action system. Since actions are essentially a reaction to user input, they must be quick, and I must get updated in time. So they naturally belong to frontend. Should they do something heavyweight and touch entities not present on the frontend, it is fine to delegate execution to the backend, but not the update. Next is PSI tree, if available for a particular language, of course. Please note that we have already migrated a lot of languages that have bundled support in IntelliJ-based IDEs. And last but not least, RPC calls also belong to frontend. The next list is purely backend APIs. First, it is a virtual file system. Next, indexes, again very heavyweight. Then goes version control system, as well as external processes related stuff. It might be executil, process handlers, run, debug, or build related stuff, and so on and so forth. PSI tree is here again, because usually it is a shared entity, in fact. Frontend does need it because it handles typing, while backend might need it to perform some heavy and possibly even project-wide analysis, like inspections. Next thing in the list is remote topic. It's a sort of reverse RPC, meaning that it's a backend-initiated signal to the frontend. And last, RPC implementations belong to backend as well. Okay, let's summarize this talk with a step-by-step guide on how to create or migrate an IntelliJ plugin to make it remote development friendly. First step is to create a set of modules. Use the provided template as a reference. There will be shared frontend, backend, and maybe some other modules of your choice, but this is the baseline. Next step is to decide whether your plugin is more UI-oriented or it has more business logic code in it. After making such a decision, you have to move existing code to one of the modules we recently introduced. If it's UI-heavy, move the code to the frontend module for the sake of simplicity of further refactoring. Otherwise, if it's logic-heavy, move the code to the backend module accordingly. Let's assume our plugin has more UI-related code inside it and less business logic. It makes sense to try having all the code in the front-end module and then switch to the next step, which is very crucial, by the way. It sounds rather simple, yet it requires quite some attention and analysis. It is to identify the boundary between the UI and business logic. For instance, if there is more UI-related code in the plugin, we have to find where the components do get their data model from. Then, we'll have to extract the backend-specific code into its own module, which we have luckily created on one of the previous steps. You might expect broken compilation at this stage, and that's totally fine. It's going to be addressed really soon. Next step, it's number 4, I believe, is to introduce an intermediate abstraction layer. Let's call it remote feature module. It should belong to the front-end module. We will now start fixing compilation issues introduced on the previous step. To do so, we have to replace direct backend API calls in the frontend module with this very new abstraction we have recently introduced. Finally, in our new remote feature model, we'll have to employ RPC to get the actual backend model state. Where there was a request to find a file in the file system, there will be an RPC call that schedules this operation on the backend. Where there was a search for all usages of a particular Java method declaration, to estimate their number, for instance, there will be again an RPC call that retrieves the information from the backend, who actually knows about Java, its declarations, as well as the other files in a project. Either we can make a direct RPC calls on background threads, or we can introduce a more sophisticated distributed model with eventual synchronized state and use it on the front-end side. The model will get subscribed to the backend state updates and will eventually reflect these changes in your UI component. And we're finally done. Congratulations. Next, I have a few really frequently asked questions which I'd like to address before switching to your questions. And first of all, it is, well, how does the suggested plugin architecture work in a monolithic IDE? And the answer is just fine, because the monolithic IDE is essentially both front-end and backend in a single process. All dependencies will be satisfied, and RPC calls will be just a suspend function calls with little to no overhead. So you don't have to worry about it. A single architecture for your plugin, which will work in any environment. The next question is it even safe and secure to send some data over RPC? And the answer is yes, it is. Our protocol, which we use underneath the RPC, is encrypted with TLS. So no worries about it either. And the last question is whether it's okay to call RPC methods during UI components initialization. And here the answer is no, it is not. Please consider either fetching the necessary data beforehand, under a progress indicator by the way, or implement a background data synchronization between the backend and the frontend. And always work with the data snapshot that is already available on the front-end side. And that's it finally from my side. Thank you very, very much for your attention. Your questions are very welcome. Please.
Thank you, Nikita. So finally, we have you live here. Hi.
Hi. You're very welcome.
Great detail, very good practical advice also, and last but not least, applause for doing this pre-recorded, because this is takes some time. Yeah, I know.
Thank you very much.
I can imagine. So yeah, we have a couple of questions. It was actually also very interesting to see this, with the background about writers work there with remote development. But yeah, one question that I'm really curious to ask is how do you actually test this, under certain conditions? Like something that I remember from web development is that you can select, okay, what is my connection? How much data can it transport? Do you have something similar for testing remote dev scenarios as well? Or how do you prepare for problematic situations?
That's actually a good question. I should have covered it in the presentation. Yes, we do have a quite easy opportunity to test the remote development setup, which is called like connection widget. To be able to access it, one has to enable the internal mode in the IDE, I believe, and that's all the requirements. And on the upper left corner, there will be a widget with actually many settings in it. But what you should seek in it is a direct delay option. You simply specify some value in milliseconds, like 100, 1,000, or whatever you choose. And that simulates a connection, like poor quality connection, okay? Mm-hmm. And with this setup, you can just click in your plugin features, like test the UI, test some I don't know, completions, whatever it provides, and see whether the feature, a specific feature you are developing at the moment, is affected or it is not. That's it. That's what we mostly use ourselves. And of course, you can try the real world setup, but it's a little bit more complicated. So for local development, it's really good one.
Exactly, and also start an ISO download during trying this out. Okay, so internal mode and connection widget, it was called, right?
Yes, correct.
Yeah. All right. Thanks. That sounds good. Another question, Patrick or Jacob? Any one of you wants to ask a question, or should I ask all the questions? I'm also fine with that.
You have one from Joachim.
Sorry, yeah, we got a question from Joachim in chat. So Joachim asks, are common features like inspections and intentions remote friendly by default, or would I have to implement this for each of my inspections and intentions?
Got it. Good question. So inspections, it's definitely yes. In general, all the highlighting related stuff, be it inspections, annotators, maybe we do have something else that remember quickly. They naturally belong to the backend, I would say, because they usually require some additional knowledge, either about the project, about the files, about name your technology here. So they work there and they deliver the ranges they would love to highlight and some fixes as well to the front end where they get applied to the actual editor. As for intentions, here I would say it's a little bit more complicated. By default, they do belong to backend as well, so they will work definitely. It might be that if the intention affects a very let's say it's a really local thing, so it does affect only the current file, or maybe I don't know what exactly your specific intention does. It might be better to register it on the client side so that it just gets executed quickly. But in general, I would say that it works fine out of the box.
So I maybe have a question regarding that, because I think intentions and my question about action. So when I think about an action, right? So right now you have basically all the implementation. So you have the front end implementation into one file. And when I understand you correctly, now I have to split it into back end and front end, right? So for an action, I have basically the quick check if the action is available, which should run in the EDT. And then basically the hard stuff, when you invoke the action, is not run on the EDT, or can access basically the real heavy backend stuff, right? So do I need to split up the action code now into the hard part, which goes into the backend module, and the light part that stays on the front end? I'm not sure I got that.
Okay, so small correction before I try to answer the question. When I spoke about actions, I meant like the real action system API, which is an action class.
An action, right? Yeah.
Yes, and what it does internally is essentially two methods. It's the update, and second is action performed. So update is executed. It not only gets executed on the EDT, by the way, but it should be executed on the front end side so that the update doesn't get affected by the latency. Otherwise, you'll see this weird loading indicator somewhere in the context menu, for example, and that doesn't really make sense. And usually the update is quite simple, so it is enough for it to just check whether I am displayed in some specific place, which is correct. Maybe I'm touching the right file, which the action is applicable to, and that's fine. But the action performed, it's a little bit different story, because it really depends what the feature is. If the action performed actually does, I don't know, print something to console, okay, you may do it on the client side and do not split the action.
Let's assume it's something heavy, right?
Yes,
it's something really heavy.
If it's something heavy, it probably belongs to backend, because it usually touches entities that are registered on the backend and that belong to the backend. And in this case, it makes sense to just extract the implementation of action performed method into the backend module and connect them via RPC as I described. That's it.
Okay.
So usually it's like a reasonable amount of job.
Okay. It's highly interesting topic, by the way. It's really nice, right? I mean,
yes, and it's also evolving. So we do realize that something is still not like far from perfect, but we're working on it. I promise it will get better.
if no one has a question, I have another one. Okay, I shoot. So
Go ahead.
I mean, it's not remote development, but we have Code with Me, which touches a similar topic. I type something and it needs to be synchronized with the other client who is coding with me. Will basically your work on the remote development influence that? So basically, that Code with Me works better.
That's
You're
a
laughing.
very good question.
I see you laughing.
I'm thinking. So honestly, I don't have a really good answer to this question because it. Sorry, again, it depends. In general, one may implement a remote development friendly feature which will also work well in Code with Me, but that requires additional efforts because many clients, you have to maintain this connection between the backend and the first client, the second, and all the rest of them. Some features are like client independent, so you show the very same content, and in this case it is like literally the same as remote development. But others, they are not that simple, and they will likely require something else. I'm not sure what exactly. It again depends. So
Okay.
in the scope of this presentation, I decided not to mention
Not
it
to touch.
because
Okay.
it's too complicated, I think. Let's start with remote development, and as soon as it works well, we'll think about the many clients case.
Fair enough. I think we got another question from Joachim. Are read action, write action, and so on expected to run only on the back end, or are there additional threading requirements for split plugins?
Good question as well. Thank you.
We're asking the hard ones here.
Yes. So let's split the question into two parts, probably. So read and write logs, read and write actions, they exist for the cases when your feature touches any project-related module, be it PSI, like file system, maybe something else. And in case, for example, if you do touch those systems on the front-end side in your split plugin, that just does make sense to employ the very same approach you did before in the monolithic plugins. For example, if you do work with PSI. As for anything other than the existing APIs, there is nothing, I think, nothing specific. So it's just a good practice, or okay, it's not even good practice, it's a requirement not to try invoke RPC calls on EDT because it's a very bad practice, and it will you'll end up having either freeze or some weird behavior, just like with any other IO operation which is done on EDT. Other than that, I think that's nothing else. I might be missing something, but what comes to my mind quickly is that.
All right. So if there are no other questions.
It's interesting, Patrick. I had a very similar question to yours, but related to the RD protocol and Rider, because I think they faced a similar architecture, but not the problem of it doesn't happen on a single machine, So they had the problem of communicating between front and back end, but all same machine, so no latency probably, but still keeping data in sync and etc. So yeah, we're the same thought there.